solving compound inequalities. Previous objective was to solve absolute value equations with two cases. Today, we are going to solve compound inequalities containing the word and then graph their solution set. And then we're going to solve compound inequalities containing the word or, and then graph their solution set. Those are two big objectives. Make sure you get those copied in your notes, along with 3 vocabulary words. A compound inequality is 2 or more inequalities that are connected by the words and or. Basically, that generalizes our entire lesson for today. Then it breaks it apart into intersections and unions. An intersection contains the word and. So when you see intersection, you should see the word and. Inequalities connect and the solution is between 2 points. A union contains the word or, and inequalities go in the same direction or in the opposite direction. This will make more sense once we get through some examples. Make sure you get the vocab written in your notes. You'll find it helpful when you start to do your assignments. First example is to graph an intersection. All right, if you notice here, we have 2 different problems. So how to set this up is to start with 7 is less than z plus 2, and then solve z plus 2 is less than or equal to 11. We have 2 different equations here. What I did is I took the first part of it and solved it there, and then took the middle and the last part, and we're going to solve it there. So I'm going to subtract 2 from both sides, and I get 5 is greater than z. I'm going to subtract 2 from this side, and I get z is less than or equal to 9. Now when you see the word intersection, that means that you're going to put your variable in the middle. As you see, your variable's in the middle, and it's written just like this. Because what this means is that z is greater than 5, but less than or equal to 9. Okay? So just to recap, we broke it apart into 2 different equations and we solved them both. And then we rewrote it. So our solution, z is in the middle, z is greater than 5, but less than or equal to 9. All right, now it says to graph it. So z is greater than 5 is an open circle at 5 going in this direction. And z is less than or equal to 9 is an open or closed circle going in this direction. So my final answer is to find the intersection of between the 2 points. So your answer would be 5 with an open circle connected to 9 with a closed circle, meaning that that inequality or that compound inequality, any solution falls between it's greater than 5 but less than or equal to 9. All right, so we're at a checkpoint. So if you want to try one on your own, we can come back together and see if we get the same answer. All right, so I'm going to break it apart into 2 different parts. I have -5 is less than or equal to x minus 1. So I took the first half with this ending, and then I'm going to take the middle with the last half. So x minus 1 is less than or equal to 2 are the 2 equations that I'm going to be solving. So I'm going to add 1 to both sides, and I get -4 is less than or equal to x, and I'm going to add 1 to both sides on this equation, and I get x is less than or equal to 2. So I have my x in the middle, so it's greater than or equal to -4, but less than or equal to 2. So when I have to graph this on a number line, I have -4, -3, -2, -1, 0, 1, and 2. It's a closed circle at 4 and a closed circle at 2. And my solutions are everything greater than -4, but less than or equal to 2. And that is the correct answer. That you would show me this equation, and then it would follow that graph. Closed circles, connecting in the middle. That's the intersection. Think an intersection that both of your inequalities are going to meet in the middle. So we're at the multiple choice question. Same rules apply. It's a intersection. So you're going to use the word and. You're going to first solve this equation, then solve this equation, and tell me A, B, C, or D, which is the correct answer for this compound inequality. All right, now we are to unions. Unions contain the word or. And what that means is, again, that your inequalities are either going to go in the exact same direction or they're going to go in opposite directions, but they will not meet in the middle. So let's get started and take a look at what that looks like. I have 4k minus 7 is less than or equal to 25. And then I have 12 minus 9k is greater than or equal to 30. So the first thing I'm going to do over here is add 7 to both sides. And I get 4k is less than or equal to 32. Divide both sides by a positive 4. So k is less than or equal to 8. I'm going to subtract 12 from this side. And I get negative 9k is greater than or equal to 18. And because I have to divide by a negative 9, I have to flip my sign. 18 divided by negative 9 is negative 2. All right, so those are my two solutions. So next, on the next slide, we're going to talk about how to combine them and graph them. So I graphed k is less than 8, less than or equal to 8 with a closed symbol on 8 going in the left direction. And k is less than or equal to negative 2 is going in this direction. Notice how from negative 2 on, they're all covered. So the union is really between those two. So our answer contains every point on the graph starting from 8 downwards. So the answer, or the solution set, is k is less than or equal to 8. So this is an example where your union, or both of your compound inequalities, will go in the exact same direction. So your solution is really just one answer. Because k is less than negative 2 fits in to everything less than or equal to 8. So we are at a checkpoint. You can go ahead and pause the video if you'd like, or follow along and take a look at the next example of a union. We have 3x is less than or equal to negative 6, and we have 2x minus 6 is greater than or equal to 4. Well, this side, the only thing I need to do is divide both sides by 3, and I get x is less than or equal to negative 2. And when I add 6 to both sides here, I get 2x is greater than or equal to 10. Divide both sides by 2. And x is greater than or equal to 5. So now I'm going to graph it on a number line and take a look at what that looks like. I have negative 2, negative 1, 0, 1, 2, 3, 4, 5. It's a closed circle at negative 2, and it is going in this direction. And it's a closed circle at 5, and it's going in this direction. So again, unions, you have two possibilities. They can go in the exact same direction, either both going left or both going right, or in this case, they go in opposite directions. Both are examples of unions using the word or. Now you are going to have, you are going to have a few examples in your homework that is a union that is either all real numbers or no solution. So we're going to take a look at two examples, and I want to show you some examples on what this actually means. So for the first example, I have 22 is greater than 4m minus 2. So I'm going to add 2 to both sides. I get 24 is greater than 4m. Divide both sides by 4, and I get 6 is greater than m. Now when I solve this one, 5 minus 3m is less than negative 13. I subtract 5 from both sides. I get negative 3m is less than negative 18. Divide both sides by a negative, and I get m. I have to flip my sign. I divided by a negative, but a negative divided by a negative is a positive. All right, so I just put the variable first on that example. It's going to help us when we graph. And notice that both of my solutions are 6. This one is everything less than 6, and this one is everything greater than 6. So notice that even though it's an open circle at 6, it would cross over with each of the solutions. So our answer would be all real numbers. Okay? Because every number on the number line is accounted for. All right, I'm sure you can assume that the answer for this would be no solution, and I'm going to show you why. We have negative 4a plus 13 is less than or equal to 29, and 10 is less than 6a minus 14. Well, the big red flag here is that you're solving a union and you're using the word and. And if you remember from the beginning of the lesson, ands are intersections and they're supposed to meet in the middle. So let's take a look, because unions use the word or, not and. So I get a, I have to flip my sign, I'm going to divide by a negative 4, and I get a is less than or equal to negative 4. This one I'm going to add 14 to both sides, and I get 24 is less than 6a, divide both sides by 6, and I get 4 is less than a, so a is greater than 4. All right, so for this example, I have negative 4 is in a closed circle, and it's going in this direction. And I'm down here at positive 4, and it's an open circle going in this direction. Well, the word and represents an intersection, meaning that these two should meet in the middle, but they don't. They're going in opposite directions like a regular union. So this example would be no solution. And I wanted to point this out. You do have one in your homework, and we will talk more about it on when we get together tomorrow. But I wanted to show you that the importance of the words and or play a role in whether or not it's a union or an intersection, and what our inequalities, the direction should be. All right, we are to a open-ended question on your Google form. So it's the word or, so we know it's a union. So solve for x in both equations, and I understand that you're not going to be able to graph on the open-ended section in your Google page. So just get it down in your notes and solve for x, and we will talk about it when we meet again. Okay? Thanks, and I'll see you again for the next lesson.